Let's look at some exam questions regarding these first two lessons of vectors. All of these can be found in paper ones again, at least until 2020, if I'm not mistaken. So let's start with a paper one from June 2005, and we are looking at question 11. Relative to an origin O, the position vectors of the points A and B are given by, and then you have there the position vectors. Use a scalar product to find the angle AOB correct to the nearest degree. That's the first question. Find the unit vector in the direction of AB, and then I'm going to read the last question. So this is actually very simple. You have here the reproduction of the vectors OA and OB. You know that the angle between OA and OB is going to be given by, well, the formula that you already know. You have here all the components, multiply the x components, add with the multiplication of, or the product of the y components, add to the product of the j components, divide the whole thing by the product of the moduli of OA and OB, which is square root of the square of all components added together, and you have the angle. As simple as that. And then find the unit vectors in the direction of AB. You first need to get the vector AB in component form. So that's OB minus OA. So do all of this minus that. This is what you'll get. Get the moduli. Get the modulus of the function. Get the modulus of the vector, which is 7. Then the unit vector in the direction of AB is going to be each one of these components divided by the modulus. And now question 3. It says, the point C is such that OC equals, say, 6j plus pk, where p is a constant. Given that the lengths of AB and AC are equal, find the possible values of p. This is just simultaneous equations. So this is the condition that you need to use. So what is the value of AC? Is OC minus OA. So is this minus OA? Here you have it in terms of K. What is AB? AB is, now you know that the modulus of AC equals the modulus of AB. So the modulus of AC is given by the square root of the sum of each component square, which equals the modulus of AB, which we already got from the previous question. All right, so it's just solving this equation. Okay, simple enough, and eventually you'll get to the two values of P, the value of P and the value of Q. Now, this is a paper 1 again. This one is from October-November 2008. We are looking at question 4. It actually takes more time reading the question than answering it. All right, all of that to say that the diagram shows a semicircular prism with horizontal rectangular base ABCD. The vertical ends AED and BFC are semicircles of radius 6 centimeters. The length of the prism is 20 centimeters. The midpoint of AD is the origin O. The midpoint of BC, over here, is the M, and the midpoint of DC is N. The points E and F are the highest points of the semicircular ends of the prism. The point P lies on EF such that EP equals 8 centimeters. Unit vectors I, J, and K are parallel to OD, OM, and OE, respectively. Express each of the vectors PA and PN in terms of I, J, and K, and then use scalar product to calculate the angle APN. All right, I've drawn here the AP and the PA and the PN. This is the angle that you want. Okay, let's express PA in terms of I, J, and K. So PA equals OA minus OP. What is OA? That's just minus 6i. That's the only component that you have. You have nothing in z and nothing in y. What is OP? OP, to get to OP, there's nothing in I, in the x component. You just need to go 8 units to in the direction of j and 6 up in the direction of k. Okay, so just applying the formula, this is what you get. Pn is On minus OP. How'd you get to n from O? So it's just 6i plus, if this is the midpoint, it's going to be half of that, plus 10j. Yeah, and there's nothing in the z direction, so there's nothing on k. All right, so that's what you have over here, minus OP. We already saw that, how much that was. So this is the result. The angle is just applying the formula. Okay, actually much simpler to solve than to read. Now the last one, it's another paper one. This is October-November 2007, question 10. Okay, another diagram which shows the cube OABCDEFG, in which the length of each side is 4 units. The unit vectors IG and K are parallel to OA, OC, and OD. Respectively, the midpoints of OA and DJ are P and Q, respectively, and R is the center of the square face ABFE. Express each of the vectors PR and PQ in terms of IJ and K, and then use a scalar product to find angle QPR. Okay, these questions are very typical. All right, so PR is OR minus OP. What is OR? In order for you to go from here to here using IJ and K, you need to go for I to J and to K. For OP, where is P? Is over there. That's just 2I. So this minus that is just this. What about PQ? PQ. That's OQ minus OP. OP, you already know what it is. All right. What about OQ? In order for you to get to Q from O, you need to do 0I, right? It's just 2J plus 4K. So this is the result. It's already expressed in terms of IJ and K. The angle is just applying the formula. Here you have it. And then finally, question 3 is find the perimeter of triangle PQR, giving your answer correct to 1 decimal place. To get the perimeter of the triangle, you need to get the distance of each side. So that's the magnitude of PQ, magnitude of PR, magnitude of QR. Starting with QR, that's the only one that you don't have the vector for. So again, that's OR minus OQ. OR is given by 4I plus 2J plus 2K minus OQ, which is 2J plus 4K. Subtract the letter from the first, and there you have it. So the magnitude of QR is going to be square root of this square plus that square. That's square root of 20. Then the magnitude of PQ, just use this, and you'll have square root of 24. Magnitude of PR, just use this, and you have the square root of 12. So the perimeter is the sum of all these square roots, which rounded to 1 decimal place, as the question asks, is 12.8 units.